what I want to explain is how to do the Millikan oil drop lab. And what we're going to do is, sadly, we're just going to do a simulation of it using software. You should actually be very glad of that. The actual apparatus must cost thousands of dollars. It's the size of a Buick, right? And years ago, honest to God, it's like this thing about the size of this, right? And you're actually looking through a microscope at almost nothing. They're like these little droplets, and you've got this knob, and you can adjust the voltage up, and you can adjust the voltage down, and all this stuff. And the problem is that when you look in a microscope and there's nothing there, don't you sometimes see things? Yeah, those things are in your eye, yes? There's like crap floating around in the clear stuff of your eye. And sometimes you see those, especially if you're looking at something like the sky that has a flat field, right? You'll see them. Right now you don't see them because there's so much stuff and you can't distinguish them, right? But I do believe that for like a half hour I thought I had a droplet, and it seemed to me to be responding to the voltages, right? And it turned out to be just like something in my eye that I was looking at. It was just like floating around. In fact, I can see it now. I'm looking at that. Yes, there it is. And as I changed the voltage, it seemed to move up, but it didn't always move up. In fact, in general, it just kept falling. I kept turning the voltage up higher and higher. Yet my drop, anyway, these drops won't do that. These drops are going to be very, very well behaved. Now, what we have so far is we've got a formula for Q. And what's our formula for Q? You guys all turned in your Millikan prep, didn't you? And it's in your Millikan prep where it is, yes? Does anybody still have their Millikan prep? Yes, okay. Shh. Can everybody else be quiet? Okay, what is our formula for Q? Here, I can do it. Okay, shh. Can we be quiet? Hello? Guys, so I think it's V over D times Q is, what is it? It's rho times 4/3 pi r to the third times G, correct? Yes. Yes? And then we solved this. This became D, then there's a V on the bottom, right? The 3 comes down there. And I think that's our formula for Q, isn't it? Correct. Yes. There we go. Okay. Now, the problem with this is that this is Q in terms of, well, the density of the oil we're using is something that's well known. The acceleration of gravity we know. In our experiment, this is going to be 3.1 millimeters, so 3.1 times 10 to the minus third meters, right? This guy's going to be 9.81. This one I think is like 128 kilograms per cubic meter, right? Okay. And then this is the voltage that we're suspending, and that'll be something that we can record, right? But the problem is that we don't have R. So what we need to do is we also need to use our formula for R, which is, what is it? The square root of 9/2. What is it? There it is, UV, right? And then this V here is velocity, right? So basically this just means that drops that are bigger fall faster, correct? Yeah? If you double the size of the drop, then what does that do? Does that quadruple your speed? I think it does, doesn't it? Yeah? If this is doubled, you'd have to quadruple that, wouldn't you? Yeah? Something like that, right? Okay, so here's our flow chart. Basically, we're going to get a new drop. Right? Get a new drop, right? Okay. Then we need to also, the next thing we need to do is determine its size. Okay, this is our little flow chart for existence, right? Determine its size. We're going to do that by letting it fall. Okay, we're going to free fall, or we're going to drop it 3 times. We could do it more times, you know, but good scientists get at least 3 trials, don't they? Yeah, yeah. Okay, so determine its size, right? And then basically, once we've determined its size, it becomes valuable because we've just spent 5 minutes determining its size. Yeah. Okay, and then once we've done that, then we can zap and suspend, right? Zap, suspend, and I'm just going to use musical notation here, right? ad infinitum. Right? You know? We're just going to repeat, right? Zap it, suspended, and you're like, what is zap? Well, what Millikan did was once he had the size of the drop, and it's really painful to figure out the size, you have to like drop it, time how long, literally with a stopwatch, how long it takes to drop, measure the distance it drops, right? Bring it back up, drop it again, bring it back up, drop it again, right? Till you're sure you know how far it drops in what time. Then you know the velocity, right? Then you know the size, then you know this, and we know everything else, and we can determine the Q. That's our goal. Now, backing away from it, why are we measuring the charge on these drops? Why are we measuring the charge on the drops? Because, see, the drops are like that other data you did for the Millikan prep, right? There's some amount of charge, and the charge on one of those drops could be 13 electron charges, right? It could be 17. It could be 19. It could be 18. It could be 21. It could be 32. It could be 45. But it never ever is 6.17528. Yes, correct? Why not? You can't have half an electron or a fraction of an electron. You either have an electron or you don't have an electron. So when you graph charge, if you get enough charges, your graph is going to look like this. Ultimately, your graph of charge, if you sort it, right, is going to go. It's going to have steps in it, yeah, just like that graph that we looked at. Okay, and the size of those steps will be, if we're lucky, an electron charge, right? So we're going to do exactly what we did for the Millikan Prep Lab. We're going to graph it. We hope that we get steps when we do Q, and then we sort them this way, right? Okay. So let me just show you how to get a new drop, how to determine its size, and then I'll show you zap suspend. Okay. So on the desktop, you're going to look for something that says, can we stop? You're looking for something that says the Millikan Lab, right? And it says Pentium 3. I had to go in there and tweak it so that it didn't run too fast. Like you had to, it was designed for, I think you could just run mil-x and no signal. That's not good, is it?
It's on your computer. It's just not showing on your
Okay. Isn't that funny?
Yeah.
Come on, baby. Let's see if I hit enter, will it come back? It's over there. Come on, baby. I have a solution. Tengo un solution. Yeah. What? Una solution. Lo siento, amiga. Okay, why will the cable not go on there? Come on, baby. Veni, vidi, vinci. Je suis le roi du monde. Oui, oui. Attention, s'il vous plaît. All right. Now, check this out. Okay, well, the mouse does not work on this, does it? Okay, so if you look at this, it's telling us all sorts of things. This is our zoom level. Every division here is 77.5 micrometers. That's what it means.